Hello. So let's start by going over the problem. The Occupational Safety and Health Administration, otherwise known as OSHA, provides safety standards for workplaces. And then here it says, the ability of a ladder to sustain the loads indicated in this paragraph shall be determined by applying or transmitting the requisite load to the ladder in a downward vertical direction when the ladder is placed at an angle of 75.5 degrees from the horizontal. Okay, so with that information, let's go on to the problem. First part of problem A states, if you have a 25-foot long ladder that is set according to OSHA standards, how far up the wall will the ladder make contact? So let's look at that over here. We're going to start with, go over here, okay, start with this. If we see on this ladder over here, we know that this measurement right here is 25. And I'm also going to write it on paper as well. Let's just move this out of the way for now. We can remember what it says. Okay. So we know that, let's start over here. Okay. The length of the ladder right here is 25 feet. Which is this right here. All right, so then we can see from this that there's a triangle. So we can go to the corner, and then from this corner to that corner. Now this is a bit of a warped image because it's an image of a ladder with perspective. So I'm going to move over to the paper, and we'll continue the problem over on the paper. Okay, so over here on the paper, you can go mark this out, which represents the wall, which we want to figure out, the red. And then over here, the blue is the distance from the wall, the distance of the ladder to the wall. Now, if we pull up OSHA standards again, it says that there has to be placed at a 75.5 degrees from the horizontal. So we know that that is referring to this angle here. This angle here. All right. So, So we can add to this image that we know this angle has to be 75.5 degrees to meet OSHA standards. And we already know that this is a 90-degree angle from the wall to the floor. So what we're trying to figure out is this height right here. How high up the ladder touches the wall. So we can start this off by going over SOHCAHTOA. So out of these three options, sine looks like it's going to be the best bet for us because the sine of theta is opposite over hypotenuse, and since we're trying to find, since we have this right here and we're trying to find this, we can do opposite over hypotenuse, and that should get us where we're going, because it'll look something like sine of theta is opposite over hypotenuse. And so we just need to plug in the values that we have here into this. So we're going to do the sine of 75.5 equals x over 25. So we can get our calculators out and find what the sine of 75.5 is. sine of 75.5 is about 0.968. So we're going to do 0.968 equals x over 25. And then we're going to multiply 25 on each side. This kind of may be hard to read, but yeah. So from here, we're going to get 24.2 approximately equals x. So we can go over here, and now we know that this red, in this case, with if the ladder is 25 feet long, we know that to meet OSHA standards, it goes up the wall about 24.2 feet. So that's part A of the problem. Let's look at part B. Part B says, how would you set up this ladder if you didn't have access to a protractor to measure the appropriate angle? Now it says this ladder, so it is referring still to the 25-foot long ladder that we used in part A. So we need to figure out how to find it without having the measurement itself, the angle measurement right here, that we know is 75.5. But how else can we figure that out? So without knowing that, if we didn't know that, let's see. Yeah, that's okay. We don't need to know that because, yeah, all right. So obviously we'll be at the ground level when we have this ladder. So in this case, we have, similar to the drawing from part A, we're gonna have, look like this, and this. But in this case, instead of finding the height, we want to find the base. So we can put y there. But since we still know it's OSHA standards, we can say that we do know that this will be 75.5 degrees when we're done manipulating the triangle. When we're manipulating the placement of the ladder. And since it's the same ladder, it'll also be 25 feet. All right, so if we go back up here, let's see what we want. Let's see what we can use. So since we know this angle, we could also use this one, which is 14.5 degrees. But since this focuses on the OSHA standards and it's mainly focusing on this, let's just stick with this measurement here. So we want to find y right here, this base of this right triangle. So that would be, so what would be helpful for us would be adjacent over hypotenuse, which is cosine. So cosine of theta is adjacent. I don't know if I spelled that wrong, but that's okay. Over hypotenuse. All right, so adjacent over hypotenuse, we're going to plug it in. Cosine 75.5 equals y over 25. So take out your calculators and do cosine of 75.5. And let's see. So the cosine of 75.5 is about 0.25. So 0.25 equals y over 25. Yep. And so we're going to multiply both sides by 25. And we're going to get approximately 6.26 feet. And the question is, why are we doing this? Because it says we don't have a protractor. But what we probably do have, is a tape measurer. So we're going to be measuring the distance from the wall to where we want to place the ladder. And we can get that distance, this blue line here, should be about 6.26 feet away from the wall. And from there, we can guarantee that this angle measured right down here will be 75.5 degrees. All right, and then let's move on to part C. Say you want to work on a second-story window. How tall would the ladder have to be if it were placed at the OSHA recommended angle? Now, there is no standard because all houses are different. There may be a modern standard, but a lot of stories of buildings vary in heights, and that it's not very common to have completely different houses with the same story height. So we're going to think about working on a second-story window. So we want the ladder to reach up to the second story. So if we go back over here, let's make it look a little more house-like. So there we go. One more time for good measure. All right, here we go. So now we have a house. So in this picture, we can see the second-story window, the ladder going up to the second-story window. And we still have this triangle we used from before, but now the ladder is not guaranteed at 25 feet because we don't know that distance now. All right, so what we do know is this. We do know that the OSHA standard is a standard for a reason, which means because of the OSHA standard, it doesn't change. The triangles the right triangles that we create following the OSHA standard of ladders will all be similar triangles because of the fact that all the angles will be the same, no matter the length of the ladder. Because we all know that this angle right here will always be 75.5 degrees. So instead of finding a measurement for this, I went a different route and found what percent would the height of the ladder, what percent would the distance from the window to the ground, what that percentage would be of the height of the ladder, because they're all similar triangles. So we can find that by using information from the last problem, since we know they're all similar. So if we look over here, and we can take the distance that we got for 25 feet and the about 24.2 feet we got for this height right here. We can look over and find, we can put that over here. It is 25 and 24.2. And to find, if we make the ladder 1, we can find that the height from the window to the second story window to the ground should be about 96.8% of the height of the ladder. But that doesn't really make sense because your house doesn't change, but the ladders do. So instead of finding a different size house to work on based around the ladder, you're most likely going to be finding a ladder based on the size of your house. So if we do that instead, we're going to find that it's about 103% of the height from your house from the floor to the top of the ladder. Yeah. So that answers problem 3. So that's how tall the ladder would be. The ladder would be 103% in terms of length of the distance from the bottom of the second story window to the ground. So yeah, and here are the sources over here. Here's a source citing the OSHA standards right down here at the bottom. And yeah, thank you. And for more about this, doing this project is this wonderful program called OBS, which I used to make this project. It was a bit long, but thank you if you watched the whole thing, and hopefully I won't see you again. Bye. Thank you for watching.